Good morning, Mrs. Full here. Hope everybody's doing well. I'm going to try to keep up with the videos for Unit 3 like I did with Unit 2 so that you have extra help if you need them throughout the unit. I do encourage you to make sure you are reassessing as soon as possible on the Unit 2B test if you need to, and I hope to see you all soon. So, Unit 3, we are going to move on and talk about polynomials instead of just quadratics, and quadratics are actually polynomials. Just a little bit more specific, we're going to do some more factoring with higher degrees in this unit. First target we're going to cover is actually 3.2. We'll come back to 3.1 later on in the unit. And it is I can write polynomial functions in factored form if you're given the zeros. Okay, so just a quick review. I'm not going to do the whole warm-up, but if I ask you to solve a quadratic equation, you can factor, square roots, complete the square quadratic formula, and then solve from there. So for example, to solve this first one, if I have x minus 5 equals 0 and x plus 3 equals 0, when I solve, I find my zeros, or my solutions, are 5 and negative 3. So you can go ahead and factor the other two, set them equal to 0, solve from there, or use square roots. But whenever we did this, we either had two real, two imaginary, or one real solution, and it just kind of depended on it. And when we have one real solution, it's actually because the same thing showed up twice. So quadratic equations have two solutions. So cubic equations then would have three solutions. Another name for the solutions is zeros. Okay. Let's go ahead and do this. So all we're going to do is we're going to take the zeros that we're given and put it in factored form. So it's kind of like working backwards from our graphing. So if I know my zeros are 5 and negative 1, think back to the last unit. I told you that anytime you take something out of the parentheses, you change the sign. So if I put it back into the parentheses, I'm going to change my sign. So if my first zero is 5, when I plug in the parentheses, I'm going to have a minus 5. And if I have a negative 1, when I plug in the parentheses, I'm going to change that to a plus 1. Okay, so those are my polynomials in factored form with those two given zeros. Okay, so number 2 says the same thing. We just have 3 zeros here, so we'll have 3 groups of parentheses. So if 2 is a 0, that means it's a minus 2 on the parentheses. So I have to change my sign. Same thing with that 3, becomes a minus 3. And then if it's a negative 10, we're going to change that to a plus 10 in our parentheses. Okay. This next one, I'm going to challenge you a little bit because I want you to think of this equation. And if I undo the work to get here, I'm going to multiply by 3 first. And then I'm going to subtract 2 for the second step. So I end up with this. It's a little different. Okay? So when we're doing this in factored form, excuse me, the first 0 is 0. So I can write x minus 0 or x plus 0. And I'll actually show you what I write here in a second. But whenever I have a fraction in factored form, the denominator goes with my x, and then I change the sign for the numerator, and that goes second. Okay, so for negative 5 halves, the denominator goes in front of my x, and I change the sign for the numerator. Okay, so just pay attention to this here. So 3 goes in front of my x, and 2 goes there. And 2 goes in front of my x, and 5 goes there. Okay, that just made it kind of messy. What you'll actually see me write is I don't usually put the 0 in parentheses with that, so on our answer keys especially, you're going to see this instead. This is the same as saying x plus 0 or x minus 0. Okay. Now we talked about when something shows up more than once with quadratics, we have one solution. What do you think it means to have a multiplicity? Okay, it just means it shows up twice. So technically, if I have a multiplicity of 2, that means I have this. Okay, so I have the same thing twice. Or I can write it, or I should write it, with an exponent. Okay, so multiplicity, we say that the polynomial of zeros are x equals blank with a sorry if you can hear the breathing in the background, with a multiplicity of blank. In writing, you can abbreviate that to mult instead of multiplicity. Okay, so now we're going to work our way backwards. We're going to tell the zeros. Okay, so the zeros here, if you set this equal to 0 and solve, I get 5x equals negative 2 divided by 5. My first one is negative 2/5. Now, some of you are going to be able to do that in your head, which is fine. So if I'm listing my zeros, I get x equals negative 2/5. This next one, I can just change my sign. Notice for both of those we have exponents though. So my negative 2/5 actually has a multiplicity of 3, and my 5 has a multiplicity of 2. And this part is really important when we get to graphing, because it's going to affect how your graph will look. This one here, if I subtract 1 from both sides, I get 5x equals negative 1 divided by 5. So for my next one, I have negative 1 over 5. No exponent means I don't have to write multiplicity, just shows up once. And then the last one is 7. Okay. So zeros for this next one. If there's nothing in the parentheses with it, it's just 0. But there's an exponent, so it's a multiplicity of 3. For the next one, I'm going to change my sign, and I end up with a fraction. And there's an exponent with a multiplicity of 2. Change my sign and a fraction, so I have 1/8, but no exponent, and then negative 3. Now, I'm doing this without showing any work. If you need to, off to the side, actually set each part equal to 0, please do that to help you out finding that fraction. So you get, that's where my 1/8 and my 2/3 are coming from. Okay, but this is my answer here. Okay, so now we're going to use that and do the other method, or go backwards, and we're going to take the zeros and write out the polynomial in factored form. So remember that denominator goes in front of my x, and I change my sign for my numerator. My exponent is 3. For the next one, it's a positive 4, so we're going to change our sign to a minus 4 with an exponent of 2. Okay, another fraction, denominator goes in front of the x, change my sign for the numerator. And now typically, some people are going to write this here, x minus 0, x plus 0. I usually just put an x in front, and that's how you're going to see that show up in your answer keys. This will not be marked wrong if you put it there though. So if you do x minus 0 or x plus 0, you're good as long as you have it there. Okay. One more, denominator goes in front of the x, change your sign for the numerator, my exponent's 5. For the next one, I have an exponent, or I have an x equals 0 with a multiplicity of 3. So I'm just going to go ahead and write it like that right away. Some of you might write it like this though, which is absolutely fine. Okay, this works as well. Okay, so that's pretty much the idea of what you're doing. In true math teacher fashion, we're going to add one little thing to it. We have something called conjugates when we talk in algebra. So if we talk about 2i, then there's a conjugate that is a negative 2i. Remember, we always use our plus or minus 0, plus or minus when we solve. So when you're looking at this, if 7i is a 0, then its opposite is also a 0. Okay, so if I'm going to write this in factored form, I'm going to do an x minus 7i and also an x plus 7i. If there's an I, there always has to be the pair there. Okay, and then if there's not an I, for the x equals negative 1, we just plug that in like we've been doing. Okay, so that works with imaginary numbers. Also works with square roots. So if there's a negative square root of 11, that means there's also a positive square root of 11. So if I have this, I must also have this. Okay. What I suggest doing to make it easier is actually list the other zeros. So if I have a positive 4i, I need to include a negative 4i. If I have a positive square root of 3, I need to include a negative square root of 3. Okay, so I have x plus 2, and then I have an x minus 4i, and an x plus 4i, and I have an x minus square root of 3, and an x plus square root of 3. Now, in Algebra 2 Accelerated, they're going to challenge your students a little bit more, and this will show up on some of your homework problems. Whenever I have conjugate pairs, I can actually simplify this a little bit more, and I'm going to let you see if you can figure out how to do that. But this is what this looks like. So if I have a 4i, I have to have a negative 4i. So those have to have a plus and a minus there. Same thing with square roots. Okay, that's it for the first unit. If you have any questions, make sure you ask. Make sure you ask, and if you need extra help, see Mr. Edelman, Mrs. P, or Mr. Becky after school. Have a great day.